Lockheed Martin's Skunk Works division, widely recognized for producing some of the most advanced and revolutionary military aircraft in U.S. history, has introduced the Vectis, a new air combat drone that emphasizes stealth, adaptability, and survivability. This new collaborative combat aircraft (CCA) drone is positioned to serve as a force multiplier alongside manned fighters such as the F-22 Raptor and F-35 Lightning II, providing a significant boost to the U.S. Air Force's future air combat capabilities. Vectis is categorized as a Group 5 uncrewed aerial system, denoting one of the largest and most capable drone classes. Group 5 UAVs typically weigh over 1,320 pounds and operate at altitudes above 18,000 feet, which allows them to conduct long-endurance missions over vast areas. The drone's size is reported to be larger than Lockheed's smaller missile-like Common Multi-Mission Truck (CMMT) drones but smaller than an F-16, providing a versatile footprint that balances payload capacity and operational flexibility. The design of Vectis incorporates advanced stealth features to maximize survivability in highly contested environments. It features a tailless airframe with a lambda wing planform, a distinctive triangular wing shape known to offer aerodynamic efficiency and reduced radar cross-section. The drone has a top-mounted air intake with an S-shaped duct, a design choice aimed at concealing engine compressor blades from radar detection and minimizing its infrared heat signature. The nose of the drone has a shovel-like shape, accompanied by chine lines running along the forward fuselage, which further reduce radar reflectivity and contribute to stable flight characteristics. Alongside its stealthy airframe, Vectis integrates conformal antennas and sensor apertures flush with the fuselage to avoid compromising its low observable design. These features allow the drone to carry a suite of sensors without increasing its detectability, enabling intelligence, surveillance, and reconnaissance (ISR) missions alongside its combat roles. At its core, Vectis embodies the principles of Lockheed Martin's Agile Drone Framework, a modular and open mission systems architecture designed to support rapid adaptation to changing operational requirements. This framework focuses on interoperability and flexibility, ensuring that the drone can integrate with existing and future command and control systems and that its payloads, whether sensors, electronic warfare equipment, or weapons, can be swapped or upgraded quickly to address evolving threats. While exact details about the propulsion system remain classified, Lockheed officials have indicated that Vectis is optimized for subsonic flight. This reflects a strategic decision based on operational analyses, which suggest that for most CCA missions, stealth, endurance, and payload versatility are more critical than supersonic speeds. The drone is designed to operate effectively in large, geographically diverse theaters such as the Indo-Pacific, Europe, and Central Command areas of responsibility, which demand extended range and persistence to support broad mission sets. Vectis currently depends on conventional runways for launch and recovery, implying it will operate from established air bases, including forward operating locations. This runway dependency aligns with its size and mission profile, distinguishing it from smaller, expendable drones or those launched from carriers or specialized platforms. One of the most innovative aspects of Vectis is its integration into manned-unmanned teaming concepts. Skunk Works has conducted simulations demonstrating how the drone can be controlled directly by pilots in manned fighter aircraft, particularly the F-22 and F-35. Using large, wide-area, touchscreen displays in the cockpit, pilots can issue commands to Vectis drones, tasking them with reconnaissance, threat detection, and offensive operations. This allows the drones to act as force multipliers, extending the sensor range and firepower of manned fighters while reducing the risk to human pilots. The drone's communication and control systems are designed to be fully interoperable with fifth-generation and future combat aircraft, enabling secure, high-bandwidth data sharing in contested electromagnetic environments. This interoperability supports real-time situational awareness and coordinated attacks, which are critical to modern air combat. The payloads Vectis can carry are flexible and likely include internal weapons bays to maintain stealth during missions. These may house air-to-air missiles to defend itself and support manned fighters against aerial threats, as well as air-to-surface munitions for precision strikes against ground targets. Advanced sensors such as compact radars and infrared search and track (IRST) systems are expected to equip the drone, allowing it to detect and engage threats with minimal external support. Beyond kinetic effects, Vectis is expected to field electronic warfare suites capable of jamming, deceiving, or disabling enemy radar and communication networks. This non-kinetic capability is increasingly crucial in modern conflicts, where controlling the electromagnetic spectrum can be decisive. Vectis is designed with reusability in mind, unlike smaller drones that are often expendable. This focus on survivability means the drone can be deployed repeatedly, which offers long-term cost efficiencies and sustained operational presence. This contrasts with competing designs that trade survivability for affordability and accept higher attrition rates. While exact cost figures remain undisclosed, the Air Force's goals for CCA drones suggest a target unit cost around $20 million, striking a balance between advanced capabilities and the economic realities of mass production. Lockheed's approach aims to deliver high-end survivability and flexibility without excessive expense. The Vectis program follows earlier phases of the Air Force's CCA competition, where Lockheed pursued a gold-plated high-stealth design but has since shifted to a more balanced approach that still prioritizes survivability but acknowledges the cost and mission trade-offs. This shift reflects an understanding that, in many combat scenarios, drones must be both capable and economically sustainable to be effective across multiple deployments. The development of Vectis is also closely aligned with broader trends in U.S. military aviation toward networked, integrated warfare. As adversaries field more sophisticated integrated air defense systems, the ability to deploy stealthy, versatile unmanned platforms that can operate with manned fighters will be essential for maintaining air superiority. Open mission systems and modular design principles built into Vectis ensure that it can be upgraded continuously throughout its service life, integrating emerging technologies and adapting to new mission requirements. This adaptability is key in an era where rapid technological advances and shifting geopolitical threats demand flexible, future-proof platforms. Lockheed Martin has emphasized the importance of interoperability not only within the U.S. military but also with allied forces. Vectis open architecture facilitates secure data sharing and coordinated operations with coalition partners, underscoring the U.S. commitment to joint and allied operations in future conflicts. The Vectis drone represents a significant advance in the U.S. Air Force's uncrewed combat aircraft capabilities. It combines stealth, endurance, flexibility, and survivability to deliver a platform capable of conducting air-to-air, air-to-ground, ISR, and electronic warfare missions in complex and contested environments. Its integration into manned-unmanned teams enhances the effectiveness and safety of manned fighters while extending the reach and lethality of U.S. airpower. Vectis reflects a mature, carefully balanced design philosophy that acknowledges the operational realities of modern air warfare and prepares the U.S. military for the challenges of future conflicts.